Hi there. Here's another little bit about the photoelectric effect, and it's in the context of what's called an open-ended question. At the end of the last lesson, we were looking at how to work out the velocity of an escaping electron after some lights shone on the metal. That's what is known as a closed question. It leads to a direct answer, and the answer is either right or wrong, and it's a number, and you get units. And there's a standard way of marking it. It gets 3 marks. You get 1 mark for the formula, 1 mark for the numbers, and 1 mark for getting the answer along with its units. Now, an open-ended question also gets 3 marks, but it doesn't have a single simple answer. It can have a whole range of different answers. So a closed question, everybody's doing the same closed question. If everybody gets it right, everybody has exactly the same answer. So many joules in the kinetic energy question. Open-ended question, you can have in a class of say 15 people, you could have 15 different answers, and all 15 different answers could score the maximum of 3 marks. I'm doing this particular open-ended question, and I'm just going to talk through some of the things, some of the pointers. So this is a previous SQA question, and it's about something called a coconut shy. And I remember when this question came up, I had a couple of boys who came out of the exam, and they weren't from Scotland. In fact, they weren't even British. And they came out and said, well, what's a coconut shy? They had absolutely no idea of what a coconut shy was. And I thought it was a little bit of an unfair question if you didn't really know what a coconut shy is. And many of you may not know what a coconut shy is. And so what is it? It's a fairground game that you get at the shows. So you turn up, you're a visitor there, you pay your £2 or whatever, and you get a number of wooden balls which you throw at a coconut, and I'm pretty sure you know what a coconut is. And the coconuts are put onto a stand, and the stand's driven into the ground, and the coconut sits up on the top of this stand, and you have a ball, and you have to throw the ball at the coconut. And the idea is that you can throw the ball at the coconut, and if you knock the coconut off the stand, you get a prize. Perhaps you can get the coconut. So I thought we'd have a look at this, because the question actually says it's helpful to have what's called an analogy, a real life analogy that can explain the photoelectric effect. So this is something you could actually see and do yourself, where a ball is thrown at a coconut, and that's an analogy for the photoelectric effect. So the question, which it's in a link, you can actually read it yourself. The question said it's often helpful to set these things called analogies in real life, which helps us to understand something in physics that you can't actually see what's going on. One of the analogies I use for the photoelectric effect is that it's a Friday night, and your dad gives you £10, for instance, and says, right, okay, you got 10 quid, you can go off and do what you like with the £10. So you might find that to get there and back into town on the bus costs £12. So that's what you've been given, and the bus fare there and back into town is £12. That's not much use to you at all. So what happens? You've got less money than the bus fare into town and back. So what happens if your dad actually gives you £12 and the bus fare is £12? Then indeed you can go to town, but that's all you can do. You can't do any more than go in on the bus, get off the bus, have a wander around, and you can't really do anything exciting because your money that you'd be given is exactly the same as the bus fare. Now, what happens if you're given, say, £18 and the bus fare is £12? Then you use £12 to spend on your bus fare there and back, and that leaves you with an excess amount of money. And how much is the excess? The excess is £6. And what can you do with the £6? You can go up to McDonald's and you can buy yourself a large burger and fries and a drink with it. So that's a sort of an analogy that I sometimes use, is that this is the incoming energy. What can you do with it? This is the work function bit here. You've been given £10. What can you do? Well, £10 isn't enough, so you don't do anything. That is scenario number one that we talked about before, where you have less energy coming in, and that's the amount of energy you need to escape. So you just don't bother. £12 and £12, that's the energy coming in. You can use it on the bus fare, but you can't do anything else once you get to town. And here you've got more money than bus fare, so you use £12 for the bus fare, £6 left over, and you can shoot off and go and buy a burger. So that's a sort of an analogy, if you like, using money and bus fares and what can you do. So what you've got to do is you've got to have a look at this coconut shy analogy, and the wooden ball that you've paid the money for, you can throw that at the coconut. And what you need to do is you need to explain how a coconut shy analogy can be used to explain the photoelectric effect. So what I think you should do is have a go at jotting down some ideas. I've already given you some ideas. You might like to think about the three scenarios that we've talked about: less, equal, and more than energy. And you can see where this is going. Now, there is no one correct answer. There's no right answer. There's no wrong answer. Some answers are just better than others. So you get marked out of 3, and you get no marks for having not a Scooby. And everything you write down has no physics relevance whatsoever, and you can't even explain it. And I can imagine if you hadn't been told what a coconut shy was, like these two boys who had English as a second language, had not a clue what a coconut shy was, and you might not either, I don't know, but no physics. Now, the thing about an open-ended question is you've got to write physics. So if you cannot think of any physics that's relevant, that ties in the idea of the analogy with the actual physics of the photoelectric effect, then you're wasting your time. And it would be helpful as well. I think it's helpful if you can actually use some formulae in your answer. That's not to say you must do, but I think it's helpful. So you get no marks if there's no physics or there's no understanding. You get 1 mark for having some sort of limited understanding of what's going on. So you might describe one of the scenarios that, if you don't throw the ball hard enough, it's not going to knock the coconut off. But if you then don't go on to explain any of the others, then you're not going to get much there. So you get 2 marks if you've got a reasonable, that was some understanding. You get 2 marks if you've got a reasonable understanding. And you get 3 marks, which is the maximum you can get, 3 marks for a good answer, which shows that you've got an understanding of all the physics. So a nice good answer. Now, a good answer does not have to be perfect. You're allowed to make a little mistake if you don't use the right words, or you can't quite explain it, and it would be up to the marker to decide whether that is a good answer and was worth 3 marks. There's some of the most difficult questions to mark, because for us as teachers, there is no marking guide. Now, I say there's no marking guide. There is a marking guide. I have given you links to both the original question and to the SQA mark scheme. But the SQA mark scheme says very little more than that. It takes a whole side of A4 just to basically say that. There is no extra stuff about, well, has the person mentioned about how hard you throw the ball, and has the ball got enough energy, and if the ball hasn't got enough energy, it's just going to bounce off the coconut and nothing's going to happen. There's none of that whatsoever. So I can set you this question on the coconut shy and its analogy with the photoelectric effect, but I can't get you to look up and see what the answer is, or what a range of answers are, because the SQA just doesn't provide them, because there's so many different answers that you could have. So I think what you could have a go at is trying to write out something. Now, because I've told you how to do it, it's got something to do with how hard you throw the ball and whether the ball bounces off. If you throw it a bit harder, the ball might just dislodge the coconut and the coconut just falls on the ground. That would be sort of like scenario 2, where the energy coming in is just enough energy needed to knock the ball off. And if you really, really throw it hard, then it's going to knock the coconut completely off the stand and the coconut's going to go flying away. So if you can link that in, those things, then you're part of the way there. If you can then actually start talking about the ball having enough energy, and that would be equivalent to E equals HF, and then the amount of energy you need to dislodge the ball is the work function, which is worked out from Planck's constant times the threshold frequency, and then anything extra over and above the work function is converted into kinetic energy. So you need some amount of that energy to knock the ball off, and any extra is just converted into kinetic energy. If you could write all that down in a series of well-explained sentences, well-structured, every sentence containing some physics, possibly with relation to the formulae, then you're well on to getting 3 marks. Now, in the higher paper, there are 2 of these open-ended questions, so that's 6 marks going. I do know, because I've spoken to a lot of pupils who've tried these, is that they tend to leave these open-ended questions till the end, because they are a little bit more difficult and it's very tricky to get a lot of practice. So this is a bit of practice I want you to get. It's just writing out some sensible sentences that describe the 3 scenarios and how that links in with coconuts and balls and the photoelectric effect. So I'd like you to have a go at that, and it's perhaps something we'll do when we get back after Easter, and I can talk to everybody and we can have a look at some answers. It's good experience to actually write your own answer and then swap your answer with somebody else, and they can judge it, and they can say, right, is that 0, 1, 2 or 3 marks? So there are links. There's links to the original question with a picture of the coconut shy, and there's a link to the marks, and it explains in a little bit more detail how you go about getting 0, 1, 2 or 3 marks. And that's it. I'd like you to have a go at that as well, having done the previous lesson. So this is 2 videos for the price of 1 to end up your final lesson of the week. Thank you very much.